Thank you everybody for coming. My name is Michael Fokin, and this is the capstone station number 1. And what this machine does is it sorts parts. There's little plastic parts and there's little metal parts. And if you look closely, some are tall and some are short. But then we also have bad parts that are in between the tall and the short, and one that is way too tall. So we have good parts, bad parts, tall, short, metal, plastic. Now this is the queue, is what I call it, and it'll push these into the station, and the station will rotate, and it'll detect whether it's metal or plastic. Actually, it'll detect whether it's metal, and if it's not metal, then it's definitely plastic. And it'll measure the height, and that'll determine whether it's good or bad. This is our beloved polishing station, and then it goes around, and then this sensor senses that there's a part for the robot to pick up, and then the robot will go from there. We do have to be careful because this is right here is our light curtain, so if you cross that barrier, it will e-stop, emergency stop the whole process, and you'll have to start over. So we're gonna get this started. Any questions so far? Okay.
We'll have some.
So we have a tall, a short, a tall plastic, and then a tall and a short and a tall metal, and then 2 bad plastic parts. There are 8 stations in total, but 3 of the stations are not being used, so they're just it's gonna keep rotating as it goes along. But in future projects, those 8 stations may be used to use a camera or to add a label or something like that to the part. Now with this project, a lot of the things that I actually had to do, because it wasn't completely finished, was add a few sensors, adjust different sensors. We had to work on the dial that the parts are on. We had to modify that a bunch of times, as well as I'm sure other things that I can't remember. So the programming side, we programmed a PLC, Compact Logic's PLC, and in ladder logic. Well, so Jeff and I worked on this together, so it feels like but I did all the programming. And I also programmed the robot. There are 6 different jobs that the robot has, and according to whether the part is good or bad or plastic or metal or tall or short, it calls that specific job and sends the part to where it needs to go. And we do have a start and a stop on the HMI to start it, but again, if you go through the light curtain, it will emergency stop the whole process, where you're going to have to take all the parts out, throw those ones away, and reset the dial, reset the system. I did consider that, but I did not do that.
Because
that would have taken me more time. It's possible. When there's an emergency, you don't know what's going to happen to those parts. And so my thoughts were that in that emergency, you may have to kind of just throw those parts away anyways, because if there's supposed to be a label on them, the label might not stick, because who knows what got on the part after the emergency stop happened.
if you have not had a class on the Espon robot, how difficult is that to learn?
It was not difficult to learn, but it was difficult because the documentation is not that great. Yes, there's 4 different screens on the HMI. There's the default auto screen, and then when you go from auto to manual, it'll allow you to enable the 4 different stations that we technically have. Well, 4 different moving parts that we have. There's the dial that moves, the pusher that moves, this polishing station that moves, and the robot that moves. And if you enable those, like there's a polisher, you can a button will appear, and it'll allow you to push the pusher out if the e-stop is not engaged. But if that button is, or that part of the machine is not enabled, then it won't allow you to push any buttons on the HMI. So that's one screen that kind of controls everything. Then there's a screen that shows what's been finished, all the parts that have been finished, because I did not count a part until it was in the sorted bin. And then there's on that screen it also shows you the current faults or alarms that are going on. Some of them don't matter as much, like it's important to know that the light curtain or e-stop is on, but you kind of just know it because you're the one that pushed it or went through it. So then you can reset all the counts, all the dials, all the alarms. You can shut those off, or not shut them off, but reset them to 0. Then the other screen is a screen that shows what part is at what station and kind of its progress along the stations. And that's one thing that I learned about the light curtain. It's great, but then it's also, you got to be careful how far you go. Then the last screen that I have is the active alarms and then the old alarms. And that's the HMI screens that I have.
Oh yeah, I would like to know what the input voltage of the system is.
There's lots of different voltages right now. There's AC and DC, 120, and then DC is 24 volts. But we also have pneumatic power as well. And I don't know the pressure that the pneumatic power is at. Yes.
Yeah, do you know how you can tell?
Yeah, just go around there and look.
I noticed that there are some new parts in the system that say bad on them. Where did those come from?
Oh, yes. I designed them. So in SolidWorks. Yep. And they say the word bad on them so that you don't get confused and try to figure out, okay, does gray mean good or bad? Or so if it says the word bad on it, it's a bad part.
Did you design any other pieces or manufacture any other pieces for this?
Yes. There's some supports under here, underneath this polishing station, so that in case it pushes too hard on the dial, it won't bend the dial as much. There's a support piece under here, and then there's a support piece under this side as well, in case the robot tries to go too far. One of the things with the robot is you can make, I tried and worked with, you can make planes, and the robot will tell you if it's inside that plane or outside that plane, and I used those to try to prevent the robot from running into this pillar. I think if I was going to do it again, there's also a thing in the robot where you can create a box, and that's what I would do instead, is create a virtual box around this pillar, and if the robot ever got inside that box, then that would be a dangerous situation. So.
And how did that go? Tell us about that process. And all projects moving forward will be using that.
Yeah. The servo drive was, from the old machines, looking at the old machines, I love the servo drive because it's a lot simpler and a lot less finicky. So with the servo drive, you have to figure out where the 0 position is. So let's say that this right here is the 0 position, but you need the dial to be rotated like 20 degrees backwards, or 20, whatever, 20 degrees forwards. You get the dial, the servo, to go to its home, and then you move it however many degrees you need to that exact position. And then from there, you can just move however many stations degrees you have. So there's 8 stations. 360 divided by 8 would be 45. And so that's how many degrees you move to go to the next station. So it was great.
In category 1, 2, 3, or 4, what would the safety category be of the system?
The safety would probably be a 4, but I got confused about that, and so I would have to look that up.
I'm asking that question for the benefit of the rest of you who may or will be doing this project at some point. Then we'll better know what your safety category is.
Emergency stops.
Different types of emergency stops built into the robot.
Right.
Which one did you use? Why?
Into the robot? Okay. So they're actually using both. There's the light curtain, and the light curtain is kind of like, let's say out of 1 to 10, it's a level 5 on the robot. And so the light curtain sends a signal to the robot and says, hey, stop, stupid. And then the emergency stop is like a level 10. And you see right here, when the emergency stop is on, the e-stop light is on. So that's like a level 10 to the robot saying, you really need to stop.
So what's the difference between the two?
I don't know exactly what the difference is, but I know that in the robot, there's two different settings, and the light curtain only shuts one of those settings off, and the e-stop shuts both of them off, from what I remember.
Controlled stop, the other is called an emergency stop, and then stop conditions, okay? So this is all part of the new system, which you need to be aware of. Very good.
So you say you are implementing both of them in your program?
It's the way it's wired up. So the way that the robot is wired up to the rest of the system is kind of how that signal is getting sent. So the light curtain sends the lower priority emergency stop, the controlled stop signal, but the e-stop is sending kind of both signals, saying you really need to stop at this before you crush someone. Yeah. What?
You wouldn't want it to stop, you might just want to go off position.
Yeah.
Or go to a hole, I guess that you would say.
Yeah, the way I did it is if it, you can move the robot around, and the way I did it is on starting the system back up, if the robot is past that plane, then move back to a safe position point before trying to go back to its home position. So.
What was your favorite part of this process?
I think all of it was fun. So let's see. Programming the robot is fun, but it goes quicker than everything else. So, half a day, a full day, and your robot's done. But programming the PLC takes a week. Doing the HMI takes a couple days. Yes. Not the robot, not the pneumatics. The problems that we came across was this sensor, trying to sense whether the part was there or not. It had a easier time sensing the metal, but it had a harder time sensing the plastic. But then also when the metal got shot out from the queue to here, the light would reflect off of the metal and say, hey, there's a part in station 8, even though that's the first part that was there. So there definitely was not a part in station 8. And so that was the reason we put this sensor over here. We are going to get rid of this sensor and put a new support over here, but we may change to a capacitive sensor. But if we do that, we'll have to put aluminum tape on the bottom of each of the parts. So then we redesigned the whole dial, and so that came up with issues and got finicky, and you know, if you don't design it in Illustrator just right, it'll print out the bad mistakes that you've made. Just so you know.
Well done, Michael.
Way to go.
Thanks.